This is an example for error propagation, and I chose the density lab, for which you had determined the error in the lab, and the formula that you used was simply determining a percentage error for each of the measurements and adding them up. That's an approximation. This one is going to be somewhat more exact, as you can find on these posted websites. And when you apply this to the equation for density, then it turns out everything is multiplication and division, and so the squares of the percentage errors, or in this case it's the decimals, which is equivalent to the percentage, are added, and then take the square root of that, and the result then is the percentage error of the result, which is the density in this case. Okay, so let's do the example. Here are some example data. So let's say we have a mass of 130 grams and an error of about 5 grams in here. And when you divide the two numbers in your head, 5 divided by 130 is a little bit less than 0.05. So we expect to come up with a little less than 5% error, and I'll show that on the calculator. So 5 divided by 130. There we go. So 0.038, that's 3.8%. As I said, a little bit less than 5%. For the length, it's 2.5 is the measurement, and the error is 0.05 centimeters, which is half a millimeter. That's what the measuring tape allows you. And again, if you divide those two, you come up with approximately 0.02, which is exactly 0.02, which is 2%. So again, 0.05 divided by 2.5, and there is that 0.02, the 2%. The same thing happens over here for the width, and in between the height, this particular measurement is a little bit different, so 0.05, the same error, divided by 2.6, so a little bit less than 2%, and there it is, 0.19%. Then you take these four results. Remember that this result is actually here twice, it's just the numbers are the same, and you add the squares of these, and then you take the square root. So that's what I'm going to do. So it's going to be 0.038 squared plus 0.02 squared, and that appears twice, plus 0.019 squared, close the parentheses, and I come up with 0.051, or 5.1% for the error. This is a little in addition to what I just recorded. Notice that in my Excel sheet I have added a few things here on the side that I didn't show earlier. Anyway, in order to determine the density, of course, we take the mass divided by the volume, and that is the 2.5 times 2.6 times 2.65, that is. And here we come up not with 8 but with 8.0 grams per cubic centimeter, because you have measured to two significant figures, so it has to be 8.0 grams per cubic centimeter, and then the error itself is determined by that 8.0 times 0.051, that error that we determined earlier. We come up with plus minus 0.4. So what that means, it's 8.0 grams per cubic centimeter plus minus 0.4 grams per cubic centimeters, and as you can see, that covers pretty well the actual true result of iron or steel, which is 7.8 grams per cubic centimeter.